Hi, my name is Brian, and today we are going to talk about one-sided limits. So when we defined, or when we introduced limits, we talked about table of values and we talked about how they look graphically. We're going to do the same thing, and so do it graphically first. So let's say we have a function like that, and okay. So we have a left hand, this is the one-sided limit, so a left hand limit which will look exactly like the general limit, except that we're going to approach a from the left-hand side, so that's coming in from this direction. And so since you're coming in from the negative side or the left-hand side, we're going to put a little minus sign there. So that's a one-sided limit. And as you follow on the graph, right, the limit value is going to be what we approach or what we expect, which is right there. And so I'm going to just call that L. Okay, so that's the left-hand limit. We can do a right-hand limit. So again, it will look pretty much like the general and left-hand limit, except that since we're now coming in from the right-hand side of A, we're tracing the graph, again, from the right-hand side. So again, what do we expect the y value to be when we get there? And again, in this case, it's L. But since you're coming in from the right-hand side, we are going to use a little positive sign there. Now, don't assume that the left and right-hand limits have to match, because they don't. When they're nice functions, they tend to. But if you have piecewise functions, so an example would be, say, something like this. So here's A. If you come in from the left-hand side, so let's call that 3, 2, 1. If you approach the graph, or approach A from the left-hand side, meaning you're tracing the graph from up here, I'm going to expect the y value to be 3. So from the left-hand side. However, from the right-hand side, if I trace the graph, I'm expecting it to go down here, which looks like a y value of 1. Now, when this happens, when the left and right-hand limits don't match, we get to say that the general limit, which is a limit without the direction signs here, we would say this does not exist because these don't match. Whereas in the previous example, since they did match here, then the general limit, limit without the direction sign, would be L. Okay, let's take a look at it numerically. Okay, so just like the graph, one-sided limits numerically would still be about how are we approaching this x value. Let's look at the limit of x to the fourth minus 2x cubed, we got plus x squared plus x minus 1 over x minus 1. And we're going to let x approach 1. So you can see how when x, you plug in 1, you're going to get 0 on the bottom. So that's why a table of values is going to be good, because we're going to plug in values really close to 1 and see what we get. So a left-handed limit, again, a one-sided limit, we are just going to choose values slightly to the left of 1. So this would be using this notation, 1, the little minus sign. I'm just going to write f of x because I don't want to write all that again. So if we set up the table, let's do that right here. Numbers slightly to the left of 1 or less than 1 would be like 0.9, 0.99. Yeah, we won't go too far. 999. And then we're just going to plug those into here. And so we're going to get 0.919. Again, the calculator over here will show you what I'm typing in, 990,199. 0.999002. Okay. So then we can say as x approaches 1, we expect the function value to, in this case, also, I guess, be 1. So you can come back up here and say 1. So the one-sided limit, which we call the other one, which is the right-hand limit, we're going to do the same thing, except now we're going to approach 1 from the right and set up the table. So we have 1.1, 1.01, 1.001. So these are all approaching 1, slightly on the right-hand side of 1. And that gives me 1.21, 121, 1.0102, 1.001. Again, rounding and what I'm showing you on the calculator could be different. Anyways, as this approaches 1, this is approaching also 1. And then since these match, we could say the general limit up here is 1. But if these were different, I mean, the left and right hand limits would still exist, but the general limit would not, again, if these did not match. Okay, so that should be one-sided limits. Hope this helped. Bye.